I give this talk a bunch. In a way, it's kind of the anti-talk of what Jay just gave, so it's the inverse. Security is a prism, man. You can look at it in so many different ways. It's called the anatomy of a secure Java web using Apache Fortress, but the principles that I'm going to talk about would work on any platform. So for the next 20 minutes, we're going to think about how we should be securing web apps if we pulled out all stops. There's my timeline. I've been at this for a while. In 1999, my boss tapped me on the shoulder and pulled me off the line and said, hey, go look at this problem. And it was a security problem. And I've been looking at it ever since. So I'm going to try to give you guys some wisdom that I've picked up over the years. This is my opinion, so feel free to disagree. There's no way we're going to get through all that. So these slides are published, or come talk to me and I'll give you a copy of it, or email me or whatever, and I'll be happy to give you a copy of it. Okay, I like this quote. There are two types of companies, those that have been hacked and those who don't know they've been hacked. And I believe that's true. So this problem statement is going to help us kind of stay focused, right, as we go through here. And what we're going to try to do is make our systems more resilient to cyber attack through the application of a few common security principles. So here we are, 2019, and are things getting better or are they getting worse with respect to security? What do you guys think? Better or worse? So not to pick on these companies up here, this could be any of us, right? That's 1.1 billion with a B right there, billion. So what's going on here? Is it a technology problem? Is it a process problem? What is it? This is the one that I've studied, which is Equifax. Okay, that's a breach that occurred in June of 2017, and it was disclosed in September. And 150 million people in North America and United Kingdom had their personal information exposed. So that's pretty much all of us. If you have a credit history and you live here, your information was exposed. So who's Equifax? You may not know who they are, but they know who you are. They're one of the big three credit reporting agencies, along with Experian and what's the other one? TransUnion. Over 9,000 employees, member of the Fortune 500. They obviously had the resources to do better. We're going to look at it here. We're going to look at this a little bit more closely, and you guys tell me how they did. So what happened at Equifax? Specifically, it was CVE 2017-5638. That's a vulnerability that was detected out in the wild in the Apache Struts framework. Apache Struts is a very common Java web application framework. It was detected out in the wild in March, and Struts did the right thing and promptly patched it, and Equifax ignored it. And a few months later, the breach occurred. What happened specifically? So it's called a remote code execution exploit, and that's where the attacker is able to trick the web server into accepting a string of data that's then executed as a system command. How did that happen? Within Struts, there's a library called the Object Graph Navigation Language that basically allows you to do things like this with a string of data. I don't know if you guys can see that, but you can basically send a string and execute it as a system command. So when an attacker can execute a system command on your server, it's pretty much game over. If you're interested in this, like I was, I believe this webcast is still out there. It has all the forensics, the tools that they used, how they think it played out. Very interesting. It lasts about an hour. Encourage you to take a look at it if this is something that you have a fascination with, like I do. So I already mentioned that Struts fixed the patch in March of 2017, but the breach occurred in, say, June or July of the same year. So obviously they didn't apply that patch. And so when they finally disclosed the breach in September of that year, as you might imagine, there was quite an uproar in the press. And Apache Struts team caught up quite a bit of it. They caught some heat. And so the vice president of Apache Struts, Renee Gielen, I hope I'm pronouncing his last name correctly, published a statement on the ASF website that I think has some wisdom that we can follow. And the first one is here. He says, establish a process to quickly roll out a security fix release of your software product once supporting frameworks or libraries needed to be updated for security reasons. Best to think in terms of hours or a few days, not weeks or months. Most breaches we become aware of are caused by failure to update software components that are known to be vulnerable for months or even years, and indeed that's what happened with Equifax. So our solution, back to the beginning, how do we make our systems more resilient to cyber attack? The solution must be to ensure all appropriate patches have been applied. How do we do that? There's a lot of ways to do that. The previous speaker mentioned the Black Duck software. I happen to use the OWASP dependency check mechanism that works on various platforms, Java, .NET, C, C++. Because I'm a Java guy, I'm using these plugins in the build tools, say Ant, Maven, Gradle, Jenkins, they all have plugins. I work on some projects, so I use Maven. You just drop a set of, you just basically enable the plugin in your POM file, and you run this target, presumably before release, and the mechanism will examine all the dependencies in your application, compare it to the NIST database, and if it finds a vulnerability, you'll spit it out in a report. So then you update the library, and life is good. Or is it? So let's go back to Renee's statement. Any complex software contains flaws. Don't build your security policy on the assumption that supporting software products are flawless, especially in terms of security vulnerabilities. So what he's saying is there's a heck of a lot of vulnerabilities out there that have yet to be detected. And there's not any kind of scanning solution today that's going to find them all. And this because, like the OGNL library in Struts, very powerful piece of software used in ways that was not envisioned. So there's just lots and lots of vulnerabilities out there. I would assert to you that the set of unknown vulnerabilities is orders of magnitude larger than the set of known vulnerabilities. So what do? How do we make our software free of unknown vulnerabilities? So let's go back to our solution with respect to how do we make our systems more resilient to cyber attack. Let's add something. Let's say practice the principle of least privilege by enforcing mandatory access controls. So how do we do that? Well, first of all, what does that mean? So within a particular abstraction layer, every module, such as a process, user, or program, depending on the subject, must be able to access only the information and resources that are necessary for its legitimate purpose. So a very simple example of practicing the principle of least privilege would be like what we do when we run our servers in production. We don't run them as root. Why? Because why would you expose that process to every file and on the system when it doesn't need that to do its job? So that's just a very simple example. Mandatory access controls, that is restrictions on even administrative users, can be enforced at a granular level. That means you turn it on and it just works. Okay, so there's a lot of different ways to do this depending on your operating environment. I already mentioned, say on a Unix system, you can run as a non-root user, run that process non-root, and that's one way of doing it, a very simple way. You got sudo, which is a way of limiting users to that. SE Linux is a well-known way of doing that. But we're talking about Java. This is a Java talk. There's a Java Security Manager. So I hear the drones in the back of the room. Java Security Manager is a much maligned subsystem. It's been around since the very beginning. Who uses it? Anybody? Nobody uses the Java Security Manager. But nevertheless, it is a way of enforcing mandatory access controls. Had Equifax run their application, I assert to you, if Equifax had run their application under the Java Security Manager, even with that vulnerability in Struts, that would not have occurred. I'm going to make that assertion to you. Why? Because it's very granular. That script that was trying to access the system wouldn't have had the permission. They would have had an access control violation. Okay, so it is a pain in the butt running it. Oh, by the way, I've got an example in my public GitHub account here with just a simple app that shows you kind of how it works that you can play around with if you want to kind of get your hands dirty with it. It's not a perfect solution. That's why nobody uses it. And I think a lot of the reason why they don't use it is because it's just hard. It's hard to get a complicated web app running or any kind of Java app running under the Java Security Manager. It takes a long time. But that time that you spend on it is actually very useful because you will understand what your application's doing in a very, very clearer way. You can see all the resources that are being accessed, and I suspect you'd probably be surprised of the things that your app's doing. But it's not a perfect solution. There's performance problems, there's problems with reflection, and there's other things that for many people they just can't use it. So what now? Do we just bury our head in the sand and just hope for the best? Or, you know, have good monitoring and hope you catch it? Well, let's go back to Renee's statement and see if he can give us some wisdom on this. So he says here, establish security layers. It's good software engineering practice to have individually secured layers behind a public-facing presentation layer, such as Apache Struts. A breach into the presentation layer should never empower access to significant or even all back-end information resources. So let's go back to the exploit at Equifax. And this is the most damning quote that I've ever read on this. The attackers used the vulnerability to pop up a web shell on the server weeks later and managed to retain access for more than 2 months, and were able to pivot through the company's various systems by obtaining an unencrypted file of passwords on one server, letting the hackers access more than 48 databases containing unencrypted consumer data. During that time, the hackers sent more than 9,000 queries on the databases, downloading data on 265 separate occasions. So there's just a little bit more than Apache Struts going on there, I would say. That's a Fortune 500 company. Okay, so let's try this again. Our solution: how do we make our systems more resilient to cyber attack? Take 3. Let's apply defense in depth. What is that? The building up, layering, and overlapping of security measures is called defense in depth. In contrast to a metal chain, which is only as strong as its weakest link, defense in depth aims at a structure where should one defensive measure fail, other measures will continue to provide protection. That's where you have this structure here, where the data is surrounded by the application, surrounded by the host, surrounded by the network. If one of those breaks down, the other one picks up the slack. Okay, so again, this is the anti-JTOC from before. This is a traditional monolithic Java web application. So, and oh, by the way, there's never going to be one set of layers for any app. It's always going to be specific to your architecture. My point here is understand those layers, whatever they may be, depending on what your runtime is, what your platform is, and then that is really, as security architects, that's our easel. That's the space that we can apply our magic, okay? So understand those layers. And if you're going to skip one, you better understand why you're skipping one. And just depending on your requirements, you might do some security in some and not in others. But so anyway, I'm getting ready to show you a sample web application, and in it, again, it's this sort of traditional web app, and these are the layers of that web app, okay? And so these layers aren't all for the same thing, so they're complementary. You can do different things in different layers. And so the outer layer, we already talked about, that's Java SE security, that's the principal least privilege, mandatory access controls. JSSE, that's confidentiality and integrity. Java Secure Socket Extension, that's private conversations. Java EE Security, that's the deadbolt on the front door. Spring Security, you can get in the front door. What pages can you hit? You can use Spring for that. Web App Framework, you can get on the page. What controls can you hit when you're on the page? What buttons pop up? What list boxes can you enter data in? Databases, content filtering. Now, again, depending on your architecture, that may not be monolithic. They may be in separate tiers. Okay, so for example, microservices, you may not, certainly probably don't have a database embedded in your web app. That's probably in a service tier somewhere. But it's, you know, there's no one size fits all here. Okay, so this example here is in my public GitHub account, and it's basically illustrates all of this. All of the instructions to do that is in the tutorial. How do you use OpenSSL to generate the cryptography artifacts? Where do you have to flip the switches? I've done all that and documented it. It's a nice exercise, even if you know how that stuff kind of works, but you've never done it. It's kind of a good thing to do. All of the infrastructure The software infrastructure is open source, so there's a database that's MySQL, there's a directory that's either Apache directory or OpenLDAP, and it's running inside Tomcat. So we're not going to go over the instructions, we're just going to look at the layers and try to conceptually understand what's happening there real quick. So those layers are under two areas of access control. You have kind of an outer area, and that's declarative, which means programmer unaware. You just enable it, you turn it on, it works. And that's to be strived for. In an architecture, you want declarative. And then in this app, I've got an inner area that's programmatic. For the web app framework and the database, I've got programmatic access control or authorization. So we started out with Tomcat. First thing we did was turn on HTTPS. We enabled Java EE security. Now this is another one like Java SE security. Everybody's like, oh, I don't want to use it. It kind of hampers the programmer's style. And so they don't understand. It's kind of difficult to use, but from a system perspective, it makes sense. From an overall system perspective, because you set it and it just works. It's a deadbolt. And programmatically, you can't break it. I once worked with an application team. They had a vulnerability in their system where the authentication form, if you entered a valid user ID and no password, it let you in. And that vulnerability was in place for years. They didn't even know about it. So you use something like Java EE security, you're pretty much guaranteed that something like that can't happen. There's a number of specifications. This is Java security talk, but it's not a Java EE security talk. So again, as security architects, you should probably understand what those specifications are and what they're for, and if you're not using them, you should know why you're not using them. This is a Tomcat app that I've got here, so it's using what's called a container standard, which is the Realm. A Realm is a database of users, passwords, and roles. There's a number of different kinds of realms. There's a memory realm, there's a JNDI realm, there's a JDBC realm that come out of the box. So I am a maintainer on the Apache Fortress project, and we created a realm called the Apache Fortress realm, which is basically a role-based access control enforcement mechanism. So contrary to what Jay said, I think RBAC's a little bit more than can a user do this, but, and let's go into that in just a second. So this application's using a policy decision point. That's how you control authorization, right? So that's basically, what's authorization? Authorization is, can I hit this button? Can I see this page? Can I update this table? So that authorization is done in what's called a policy decision point. That's a resource that's out on the network. Apache Fortress is a policy decision point, okay, and it implements role-based access control. So what is role-based access control? It's a little bit bigger than what you might think. It was basically been kicked around in academic circles for decades in the 80s and the 90s, and then it was formalized by a team out of NIST in the early 90s, David Ferraiolo and Richard Kuhn, a very influential paper where they basically laid the model out in very specific terms, which was then further crystallized into functional specifications in the 2000s by another team out of NIST led by Robbie Sandhu. So when I say functional specifications, I mean APIs. And so there's very explicit APIs, 3 sets of them to be exact. You got administrative, how do you put the policy in there? You got review, how do you interrogate the policy? And you got system, which is what do you do with the policy once you got it at runtime. Systems, what we're talking about today, these are just APIs like you would think. Authentication, authorization, adding and dropping roles in the middle of a session. Oh, by the way, RBAC has a session. If it doesn't have a session, it's not RBAC. The session is really important because that's the context for which the role is activated. Just because that role has been assigned doesn't mean it's going to be considered in an access control decision. And that's in keeping with the principle of least privilege. Okay, if you're interested in that, I've got this sample here, this role engineering sample that kind of takes you soup to nuts in what's called role engineering, the role engineering process. How do you synthesize a policy? How do you implement it within an application to enforce it? You can follow the instructions there if you want to try that out. Okay, so this policy decision point is depending on what's called an LDAP server. Do we all know what an LDAP server is? It's a special purpose database specifically custom made for security. Okay, so this is the Apache Fortress policy decision point. Apache Fortress out of the box supports 2 directory servers. the Apache Directory Server, of course, and OpenLDAP. So the instructions for either one of those are pointed to in the tutorial, and that would be one of the steps is that you would install this directory server. There's also some Docker containers to simplify that. So this is end-to-end security, so of course we're going to turn on LDAP SSL, so the tutorial is going to show you where you have to flip the bits and where the cryptography artifacts have to go in order to do that. We're going to enable Spring Security so that we have a secure policy to say, hey, I can get in the front door, you know, job E security, let me in the front door, but what pages can I hit once I can get in? And so Spring can say, hey, to hit this page you got to have this role, to hit that page you got to have another role, so we're kind of medium grain. And then finally down, or the next step would be down in the web app framework, again, authorization. This is finer grain, actually fine grain control, so this sample app is actually taking it down to the instance level with customer data. Can I access this button on this page for this customer? And then finally, we have the database, which is even finer still, which is to say, can I access this row in this table on behalf of this customer? And the last thing we're going to do in the sample app is we're going to enable DB SSL, show you how to do that in MySQL, flip the switches, so on and so forth. So that's, again, the Apache Fortress demo. So you can do things like this. You can say, hey, this user has access to all pages for a single customer, or this user has access for a single page, all customers, or this user has access to a single page, single customer, or any other way you want to do it. Okay, so am I out of time?
3 minutes.
Okay.
4 minutes.
So one thing I want to talk about in terms of authorization of policy decision point is performance, and that's something that's often overlooked. I was sitting in a talk a couple weeks ago at Scale Conference where it was explained to me that the round trip time with the policy decision point was 100 milliseconds. And I thought to myself, well, it sucks to be you, because that's ridiculous. And if that was going to be your response time, then I could see why you wouldn't want to do fine grain authorization. So Apache Fortress doesn't use a directory server because it likes to make things hard or it wants to use something weird. It does it because it's fast. And so OpenLDAP right now is down to the microseconds if your network can support it, which means that you have the ability to answer a lot of questions in terms of, you know, can I do this, can I do that? Not just, hey, can I hit this app, like we see a lot of times, which would be very coarse grained. It's all the way down to the data level. Okay, so that, again, that's out on my GitHub account. I don't have time to talk about the role explosion problem. If you want to hear, but basically, it's what it really means is with a role-based access control system, as soon as you introduce context, in this case, this sample app's customer, then your roles explode. Because you can say, hey, I've got 3 roles, I've got 3 customers, then I need 9 roles, like in this app. But what if you have 100 customers? What if you have 1,000 customers? What if you have 100,000 customers? What are you going to do? So there is a way of fixing that, and that's by adding attributes to the role activation. Remember I said there's a difference between a role assignment and a role activation. So in order to activate a role on behalf of a particular piece of context, that's kind of how it works, and the role-based access control standard actually allows that with a standard called Insights 494, which introduces attribute modifiers to the user role activation and the role to permission activation. So there is a solution for that role explosion problem. Apache Fortress implements it. If you're interested in that, let me know. I'd be happy to tell you about it. I think that's all I got time for. Closing thoughts: never allow users more than they need to do their jobs. That's the principle of least privilege. Apply security controls across many layers. That's defense in depth. RBAC may be combined with ABAC for fine-grained authorization. Here's links to these examples we're talking about. I've got a bonus one on the bottom, which is for doing it with SAML, combining role-based access control with a SAML endpoint. So instead of having Java EE security, you'd have a SAML 2.0. And this is using Spring SAML. So we support these, all of these little sample apps. So if you have a problem, let us know. Join our mailing list. We'd be happy to help you with it. And that's me. My contact information. Feel free to send me an email. Tell me how crazy I am or ask me questions. And that's, I don't think we have time for questions, probably.
We've got time for one question.
One question. No, so the question is no support for Active Directory. So that's a good question. Apache Fortress is LDAP v3 compliant. Okay, so Active Directory is sort of LDAP v3 compliant. And so it would work. It would work. We don't support it as a project. But, you know, come talk to us about it. Give us a test environment, and maybe that would change. Help us test it. Good question. Is that it? Any others?
One more. As a project, you guys planning on supporting anything besides Java-based web applications?
So the question is, are we planning on, as a project, are we planning on supporting anything other than Java? And it's a Java API. So it's a good question. So first thing I'll tell you is there's a component called Apache Fortress REST. So there is a REST API. Okay, so that's platform independent, obviously, right? And then I just started a project about a year ago. It's in my GitHub account. It's called PyFortress. So there's RBAC 0 for Python. And so that's what we have right now. And then there's other ways to do it. So if you're interested in that, if you got a platform that's other than that and you're interested in hooking in, just let us know. Be happy to talk about it. Thanks. Thanks, guys.